Welcome back. In next few classes, I will be discussing about set theory and its different aspects. First, I will start with introduction to set theory, and those who already have the basic idea of set theory, for them it will be a revision class. So first, we will see what is a set. In mathematics, a set is an organized collection of well-defined and distinct objects. So first of all, a set is an organized collection or group. Second point is it is a collection of or group of well-defined objects, and the third point is it is a collection of distinct objects. Now, as for example, here we can see a set of vowels or alphabets. We know that we have 5 vowels and 26 alphabets in English, so it is a good example of a set. So in a set of vowels we will have 5 elements, and in a set of alphabets we will have 26 distinct elements, and in a set of vowels all are vowels, and in a set of alphabets all are alphabets. Now if we say that a set of all the books in a library, then it will not be a set of properly or well defined elements, because in a library we will have multiple books of multiple subjects, multiple authors, and multiple domains. But if we say that a set of books of a particular author or of a particular subject or of a particular domain in a library, then it will be a good example of a set. Now if we say that a set of all the animals in a zoo, then this will not be a good example of a set. In a zoo we have animals of different types, different sizes, different colors and all. So if we be very specific that if we form a set of carnivorous animals in a zoo, then it will be a good example of a set. Though we have a concept of universal set that we will learn later in this class, then if we go by the concept of universal set, then with that argument we can say that okay, all the books in a library can be said as a set, and that set will be considered as a universal set. If we categorize all the books in a library, then under each category when we will consider all the books, then that can be considered as a set. So that way we will have multiple sets in a library, and when we will combine all those sets, then we can form a bigger set or a universal set that will have all the books in that library. Similarly, in a zoo, if we categorize all the animals, then in each category there will be similar type of animals, and that can be considered as a set. And when we will combine all those individual sets, then that bigger set can be said as a universal set. Otherwise, if we don't talk about universal set, then for a general set, the elements of those sets or the objects of those sets should be distinct and well defined. Now here, as you can see, we have another example, a set of positive integers. So here also the objects are well defined. They are positive and they are integers, so they can form a good set. Now I have already said the objects of a set are known as members or elements. Set is represented by a capital letter and the elements are represented by small letters. So suppose if we have a set of all the vowels, then if we represent that set by capital letter V, then it is represented as this way: A, then E, I, O, U. The set, this is one type of representation of set. We will learn the different types of representations after this, and there we will see that in one of the representations, the set is all the elements of a set is embraced by these curly braces, and the elements are separated by comma. And as I said, that the elements are represented by small letters and the set is represented by capital letter. Now if we say that A, as we can see here, that A is an element of this set V. Now this is another type of representation, A epsilon V, which means that A is an element of set V. Other than these 5 alphabets which are vowel, all other alphabets should not belong to this set. So if I take B, since B is not a vowel, so B will not be an element of this set. So we represent this way. This signifies that B is not an element of this set V. Now next we will see the different properties of a set. The first property, as you can see here, it is written as order of the element. Now suppose we have a set A where we have these 5 elements 1, 3, 4, 2, 6, and we have another set B where we have 4 elements 4, 5, 6, 7. So in this example, in the second example, set B has 4 elements and these 4 elements are arranged in ascending order. But if we look at the first set, then in set A, what we can see here that the first 3 elements of this set are in ascending order. 4th to 5th element when we go, then again we can see here that it follows the ascending order. So here when we represent a set, the order of the elements are not important. It doesn't matter. So in any order we can arrange the elements of a set. Now the next property is no repetition. Here we have a word elephant and here we have 5 plus 3, 8 letters. Now suppose if we want to form a set which will have the letters of this word, then that set will have 7 letters. As in this word we can see that E has been repeated, but when we will form the set having the letters of this word, we will not repeat any alphabet or any letter. So this set will have 7 letters. So this is one of the properties of a set, that when we will form a set, there should not be any repeated element under that set. Now the third property talks about the representation of a large set. Suppose the set A will have first 5000 positive integers. So when we will represent that set, we will write this way. First we will write few elements of that set and then we will represent by 3 dots. So that signifies that it is a large set, and this 3 dots signifies that there is a continuation of the element. And in this class itself we will learn that there is a one type of classification which is based on finite set and infinite set. If it is an infinite set, then we can represent this way. Otherwise, if it is a finite, and as I said that this is a set of first 5000 positive integers, so we can represent the last element of that set. Next we will see the different methods of representation of a set. The first method is description method. In this method, a well-defined description of the elements is enclosed within the curly bracket. So suppose if we want to represent a set of all the months in a year, then this will be represented this way. Within the curly brackets, we will be writing all the months in a year. So that will signify that within that set, we will have 12 elements, and those 12 elements will mean all the 12 months in a year. Now, as for second example, we can take what this says that a set of all the prime numbers less than 50. So when we will describe the set, then within the curly brackets we can write, or we can describe this way, prime numbers less than 50. So that signifies that this set will include all the prime numbers which will be less than 50, means till 49 we will consider. Now another example we can take, that a set of all the countries in the world starting with D. So this is our requirement. So when we will describe the set, we can within curly braces we can describe, or we can write all the countries starting with D. So this is how we describe a set, and this is about the description method. The second method is roster method or tabular form, which we mostly use. Here in this method, all the members of a set are listed and they are enclosed in curly brackets, and the elements of that set are separated by commas, that we have already seen in the introduction of a set. So as for example, if we take again a set of all the even months in a year, then it can be represented this way. So here we will give a name to that set, and that will be described, as I said, by capital letter. So here the set name is M. So M will be equal to, then all the elements will be enclosed within curly brackets, and here what we are taking under that set, we are considering all the even months in a year. In a year we have 12 months, then out of them 6 months are even months, so it will start from February and it will end at December, and all the elements will be separated by comma. So this is how we represent using roster method or tabular form. Then another example, if we take a set of all the prime numbers less than 20, so how it will be represented? The set has been represented by this capital letter P. Then all the elements are enclosed within these curly brackets, and it will start from 2. This is first prime number, and since all the prime numbers will be less than 20, so we will consider till 19. So here the last prime number 19 itself again a prime number, so the last prime number will be 19, and here all the elements are separated by comma. Then another example is a set of all the vowels in the word elephant. So here, as we can see, we have three vowels in the word elephant. E, then again we have E and A. But there should not be any repetition under any set that we have already learned as one of the properties of set. So here the set is V, that is represented by capital letter, and here within curly braces or curly brackets we have two elements E and A. Now the next representation or next type of representation is a rule method or set builder form. Now in this method, the set is described by stating a condition or property which an element has to satisfy to belong to that set. Now as for example, here a set of all the prime numbers less than 20. So here the conditions are that within that set all the elements will be prime numbers and they have to be less than 20. So here we have two conditions, and when we will represent that set using this rule method or set builder form, this will be the representation where P will represent that set. It is represented by capital letter, then that is equal to within curly braces or brackets we are representing. Here small x represents the element, and this element is prime, it is a prime number and it is less than 20. Then another example if we take, then here we can see that we have a set A where we have multiple elements, and based on this set we want to form a new set, and the condition is a new set will have all the odd numbers of A. So all the elements should belong to this set A and all the elements should be odd. So here as we can see we have 3, 7, 13, 17 and 25. These are the odd numbers which belong to this set. So when we will represent the new set B, then set B will be represented within curly brackets, and here X represents the element, and what are the conditions? X will be odd and X should belong to A, where A is this given set. Here this bar or colon mean such that X is an element of B such that X is odd and X belongs to A. So here this epsilon means that belongs to. So X, this element belongs to this set A. Next we will learn different types of set. Here the first type is finite set. And what is finite set? This is a set which contains definite or countable number of distinct elements. So if I take an example A, now here within A we have 4 elements and we can count them. This is a definite number. So this is an example of finite set. Now if I take another example set B, then what we can see here that within B we have 6 elements, 6 alphabets. So again we can count the number of elements of B. So this is also an example of finite set. So in a finite set we will always have a finite number of elements. Now there is another type of set which is infinite set. So you can understand that infinite means the number of elements under that set we cannot count. So that will be uncountable or indefinite number of distinct elements. Now if I take an example of a set, say a set of all the natural numbers, and that if we represent by n, then all the natural numbers means it will start from 1, then 2, 3, 4 and then it will continue. So it will continue means we will represent by 3 dots and then we will close the curly brace. So this will be an example of infinite set, because here this list, the number of elements will never end, it will continue. So we cannot count the total number of elements here under that set. Then if we say, suppose that we want to form a set with all the stars in the sky, then that is also we cannot count, we cannot end the counting of the stars in the sky. So if we form that type of set, then that will be also an example of infinite set. Now next type of set that we will learn is empty set. An empty set, as you can understand, that empty, so that set will have no element, and that set will also called null set. Now here we can see we have an example set B, and X is an element of B such that X is less than 1, and X belongs to a set which is a set of natural numbers. Here n represents that it is a set of all the natural numbers. As we know that natural numbers starts from 1, so if this is another condition that X has to be less than 1, then in that set B we will not have element, because the natural numbers start from 1, so B will be represented by only curly braces, and this signifies that this is an empty set. Now if we take another example, we have a set P. X is an element of P such that X is prime and X is at the same time less than 2. We know that prime numbers starts with 2. There is no prime number which is less than 2. That's why within that set P we will not have any element. So P will be an example of empty set or null set, and this will be also represented by only by curly braces. Now there is another type of set which is called singleton set. Now in this set we will have only one element, so that set will be represented like, if A is that set, then it can be represented like this. It will have only one alphabet, and that is A, suppose. Now suppose there is another set B which has only one month, which is March. So this could be an example of singleton set. Now there is concept of equal and equivalent set. Equal sets are which sets? Two sets. Now to represent equal sets and equivalent sets, we will have two sets. So here two sets A and B are said, or will be said, equal sets when they will have same elements. So suppose if A has these elements and B has these elements, so what we can see here, in set A we have 5 elements, and in set B also we have 5 elements, and all the elements of A and B are same, though their order are different, and we have already learned that the order of the elements in a set is not important, that doesn't matter. So here we will say that since A and B have same number and same elements, so A and B will be equal sets. Now there is a concept of equivalent set. Again we will have two sets, so here two sets A and B will be said as equivalent sets when they will have the same cardinality, and we know that cardinality means the number of elements in a set, so this signifies the number. So cardinality means when the number of elements of set A and set B will match, then those two sets will be called equivalent sets. The elements, the real values of the elements may be same, may not be same, but if only the number matches, if only the cardinality matches, then those two sets will be called as equivalent set. Now as for example, if we take, so here what we can see, in set A and B there are 4 elements, so n of A, we can say that n of A will be 4, and also in set B we have 4 elements, so n of B is also 4. Since both the numbers are same, so these two sets will be equivalent sets. We will not look into the real values of the elements, whether they match or not. They are equivalent sets as the cardinality matches. Now if we look at the real values of the elements, they are different. Now if we go to the second example, here in this set C and set D, they have same number of elements, so they are cardinality matches. So these two sets C and D will be equivalent sets. And if we look into the real values of the elements, here the elements are also same, though their order is different. So we can say that C and D are equivalent sets, and at the same time they are also equal sets because they are cardinality matches, and the elements, the real values of the elements are also same. So they are equal sets. So we can say that the equal sets will be also equivalent sets. So all the equal sets will be equivalent sets also, but all the equivalent sets may or may not be equal sets. So that is our conclusion is from this concept. Now the next concept is universal set. For that I will take three sets first. Now what is the concept of universal set? This is a set which has all the elements of all the related sets without repetition of the elements. So if we combine this, if we want to form a universal set combining these three sets, then that universal set will have all the elements of these individual sets A, B and C, but there will be no repetition of the elements. And the universal set is represented either by E or by U. So here in that universal set we will have elements like 3, 5, 2, 7. First we will consider all the elements of the first set, and then we will consider all the elements of B without repeating any element. So here 3 has already been considered, so we will not repeat that, and that is applicable for 7 also. So next element that we will consider is 10, then 12, and then we will consider the elements of C. Here 4 is not been repeated, so here 4 is a new element, so we will consider that. Then 6, 12 has already been considered, so we will discard that. And then 14 is for the first time it is coming, 14 is new, so it will be considered. So universal set here with respect to these three sets will be this, and it will have these elements. Next we will learn the concept of superset and subset, and there we will see that always the universal set will be the superset of the sets from which we are forming that universal set. So here U will be the superset with respect to A, B and C, and A, B and C on the other hand will be the subsets of U. So let's move on. So to learn the concept of superset, subset and power set, first we will take few examples. First we have taken a set A which has few alphabets and numbers, and then we have taken three other sets where set B has the alphabets, 4 alphabets, and these 4 alphabets also belong to set A, and these are the only alphabets which the set A has. Now set C has all the positive integers that set A has, and set D has all the negative integers that this set A has. So what we can see here, under set B, C and D, whatever elements we have, they also belong to set A. The concept of superset and subset is like this, that if we have a set A and if we have a set B, and if all the elements of set B, they are the elements of set A also, then set B will be called as a subset of set A. Similarly, here also we can say that all the elements of set C, they also belong to set A, and that happens to set D also. So what conclusion we can draw here is B, C and D, all these three sets are subsets of A. And on the other hand, we can also say that A is superset of B, C and D. The concept of power set is also related to the concept of superset and subset. Suppose we have a set A which has 3 elements, suppose 2, 3 and 4. So from this set, how many subsets we can form? If we include the empty set also and also that set itself. So first we will see how many subsets we can form from this given set. Now the first subset, suppose if it has only one element, then it could be like this. Then the second subset will again have one element, then it will be 3. Then the next subset again we will have only one element, so it could be 4. And then the next subset will have suppose 2 elements, so it could be 2, 3. Then another subset could be can have two elements, so that could be 3 comma 4, and then another subset may have again two elements, and that combination could be 2 comma 4. So earlier we have considered 2 comma 3, then 3 comma 4, and this time it is 2 comma 4. So these are the all the possibilities of subsets of this given set. Now the concept of power set is that it will be a set which will have all the subsets of the given set, and that will also include that given set also, and it will also include an empty or null set, as if we have not considered any element to form a subset. So first this set will have a set which will be empty, and then it will have a set which will have 2, then 3, followed by 4, and so on. So this is a good example of power set. I hope this class was good revision for you of the basic concepts of set theory. In the next class we will see that what are the operations that we can apply on sets. Till then, stay safe and stay healthy. Thank you.